Intro. Hello, everyone. Welcome back to the HowToAI Professional channel. Today, we're diving deep into a topic that is increasingly critical for software development teams: building a production-ready AI code review pipeline that integrates static analysis and large language models, or LLMs. As professionals, we understand that code quality and efficiency are paramount, especially in larger teams where collaboration can become cumbersome. So, how does this make a professional's work materially better and more reliable? Let's find out as we explore the problems of traditional manual code reviews, the architecture of a modern pipeline, step-by-step implementation, considerations for production readiness, and key takeaways for immediate adoption. The problem: why manual code review doesn't scale for professional teams. Let's start with the problem many of us face: manual code reviews. In small teams or startups, manual coding reviews might work effectively at the beginning. Team members are closely knit, and communication flows freely. However, as organizations grow, so do their codebases, and the number of pull requests can skyrocket. When the number of PRs increases, the manual review process can become a bottleneck. Reviewers may struggle to keep up with the demands, leading to delayed releases and increased technical debt. Moreover, human reviewers are subject to fatigue and oversight. They might miss subtle bugs or suggest improvements that don't align with project standards. This inconsistency can lead to disagreements among team members over code quality, style, and functionality. This is where we need a more scalable, reliable solution that can automate much of the grunt work while maintaining, if not improving, code quality. Integrating static analysis tools and LLMs into a code review pipeline can alleviate these issues. Static analysis tools can catch syntactical errors and enforce coding standards, while LLMs can assist with contextual understanding and provide suggestions based on past code examples. Together, they form a powerful combination that enhances the code review process. Architecture: combine static analysis, LLM review, and CI integration. Now that we've outlined the problem, let's discuss the architecture of this AI code review pipeline. A well-designed architecture includes three key components: static analysis, LLM review, and continuous integration, CI integration. 1. Static analysis. The first layer involves using static analysis tools to evaluate the code before it ever reaches a human reviewer. These tools can analyze code for common issues like unused variables, code complexity, and adherence to style guides. Some popular static analysis tools include ESLint for JavaScript, Pylint for Python, and SonarQube for broader language support. These tools can be set to run automatically on every pull request, providing immediate feedback. 2. LLM review. The second layer incorporates large language models. By leveraging models like OpenAI's Codex or GitHub Copilot, we can enhance the review process. These models can provide suggestions, refactor code snippets, and even identify potential bugs based on patterns learned from extensive datasets. They excel at understanding context and can provide higher-level insights about code functionality. 3. CI integration. Finally, to tie everything together, we need to integrate these tools into our CI pipeline. This means that every time a developer pushes code, automated tests for both static analysis and LLM suggestions will run. Tools like Jenkins, GitHub Actions, or GitLab CI can help set this up seamlessly. This architecture ensures that all code entering the main branch has already been vetted for quality. Implementation: step-by-step setup with concrete tools and configs. Now that we understand the architecture, let's jump into the implementation. I'll walk you through a step-by-step setup using concrete tools and configurations. 1. Choose your static analysis tool. Start by selecting a static analysis tool. For this example, let's use ESLint for a JavaScript project. Install ESLint by running the following command in your project directory: npm install eslint save dev. 2. Configure ESLint. Next, create an ESLint configuration file by running npx eslint init. Follow the prompts to set up your configurations based on your coding standards, such as choosing between common styles like Airbnb or Standard.js. 3. Integrate LLMs. For integrating an LLM like GitHub Copilot, ensure you have the necessary API keys and settings enabled in your IDE. Follow the documentation provided by GitHub to set up Copilot. This feature will provide contextual suggestions as developers write code, enhancing their productivity. For Setup CI, now, we need to integrate these tools into a continuous integration pipeline. If you're using GitHub Actions, create a .github/workflows/ci.yml file in your repository. Here's a simple example configuration. YAML. Name, CI pipeline. On, push, pull_request. Jobs. Lint. Runs on, Ubuntu latest. Steps. Name, checkout code. Uses, actions/checkout at v2. Name, setupnode.js. Uses, actions/setupnode at v2. With node version, 14. Name, install dependencies. Run, npm install. Name, run eslint. Run, npx eslint. 5. Test and iterate. After setting up the initial pipeline, commit your changes and push them to your repository. Make sure to test your configuration by creating a pull request. The CI workflow should trigger automatically, running the static analysis and providing feedback. Production, error handling, false positive thresholds, monitoring. Now that we have our pipeline set up, let's discuss how to make it production ready. Error handling is crucial in any automated process. Here are some strategies. 1. Set false positive thresholds. Every static analysis tool can produce false positives. Establish a threshold for error severity. For example, you might want to ignore warn level issues in the initial phase. This allows developers to focus on critical problems first. 2. Monitoring. Implement monitoring to ensure the pipeline runs smoothly. Use tools like Prometheus or Grafana to track CI pipeline performance. Monitor failure rates and review the feedback from your static analysis and LLM tools to continuously improve these processes. 3. Feedback loops. Encourage developers to provide feedback on the suggestions from LLMs. This helps refine the model's performance over time, making it an even more effective tool in the review process. 4. Training. Training your team on how to interpret static analysis results and LLM suggestions is vital. Hold regular workshops or share resources to get everyone on the same page. Key takeaways: what the viewer can adopt tomorrow. Before we wrap up, let's summarize the key takeaways that you can adopt tomorrow. 1. Start small. If you're not currently using static analysis tools, begin by implementing one in your workflow. Even the simplest setup can yield immediate benefits. 2. Integrate LLMs. If you're comfortable with advanced tools, start integrating LLMs into your IDE. They can significantly enhance productivity and code quality. 3. Setup CI. Automate your code review process through CI pipelines to ensure consistent application of coding standards. 4. Monitor and iterate. Regularly monitor the performance of your pipeline and be open to making adjustments based on developer feedback. 5. Continuous learning. Invest in training and resources for your team to fully leverage the capabilities of these tools. By building a production-ready AI code review pipeline that combines static analysis and LLMs, you'll not only streamline your development process but also ensure higher quality code. This ultimately makes a professional's work materially better and more reliable. Thank you for joining us today. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more insights into how you can leverage AI in your professional workflows. Until next time, keep coding and innovating.